Hello everyone. Today we are trying to make the memo for Mathematics Paper 2 that the learners wrote on 6th November 2023. Question 1. Truck drivers travel a certain distance and have a rest before traveling further. A driver kept a record of the distance he traveled in kilometer on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. As you can see, there are two rows for x and y. 1.1, determine the equation of the least squares regression line for the data. So we use the calculator for that. First we say in the calculator you press mode 2 for statistics, then choose 2 for the regression equation a plus bx, then you enter the values. Press AC button for storing all the values that you entered in the two columns for x and y. Then again go back to the button shift 1 for statistics. Then you choose 5 for regression. Get the value of a by pressing the number for a, then b. So here you will get a equal to negative 23, comma 8461, like that. Then b, you're going to get 0, comma 22703, etc. Now it's time to write the equation now. Y equal to a plus bx. So a you round off to 2 decimal place. Final answer must be rounded off to 2 decimal place. So it's negative 23, 85 plus 0, 23x. That is our equation of the least squares regression line. So that's 3 marks. Now, if a 1.2, if a truck driver traveled 550 kilometer, predict the amount of time in minutes that he should be resting before continuing his journey. Okay, so here 550, as you can see, it's the distance. So it's a x. So we are finding y where x is given. So it's just a matter of substituting in the formula that you found just now. Negative 23,85 plus 0,23 times 550. When you put this in the calculator, you get 102,65 minutes. Now 1.3, write down the correlation coefficient for the data. While the data is still in the calculator, you can now again go to shift 1, go to 5 for regression and choose number 3 for the correlation coefficient, which will give you equal to 0,98 rounded off to 2 decimal place. Now interpret your answer to 1.3. The answer is, as you can see, the correlation is 0,98. So you can say a very strong positive correlation between distance traveled and the amount of rest time. That is what you can comment about the answer in 1.3. Moving on to 1.5. At each stop, the truck driver spent money buying food and other refreshment. The amount spent in rands is given in the table below. So you have a list of data here. Calculate the mean amount of money he spent at each stop. Here also you can use a calculator by choosing mode 2 for statistics and then 1 for variance. Enter the values. Again you go to shift 1 and choose for variance. Then you choose X bar for the mean, and which will give you 150 as the answer. Calculate the standard deviation. Again you go to shift 1, then you choose sigma x, that is a standard deviation, which will give you 50,50. At how many stops did the driver spend an amount that was less than one standard deviation below the mean? So we only look less than one standard deviation below mean. That means you only check how many values below x bar minus sigma. Our mean is 150 minus sigma 50,50, which is 99,5. How many values are below 99,5? Only one value. So your answer is only one value. The answer is 1. How many stops? So it's only one stop, that is below one standard deviation of the mean. Okay, that is 1.5.3 total 12 marks. Let's go to question 2. In question 2, at a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on the specific day were interviewed, and the information is shown in the table below. Okay, now 2.1, complete the cumulative frequency column provided in the table in the answer book. So now we are not using the answer book, so let me write the cumulative frequency here. So cumulative frequency is frequency added 5, then you add 5 and 15 together, which will give you 20, then 20 and 13 together, that gives you 33. 33 plus 5, 38 plus 2, 40. That is the completion of cumulative frequency column. Now 2.2, how many staff members were interviewed? Always the last number is the total frequency. When you add all this, you must get 40, and also make sure that you get what is mentioned in the okay, it's not mentioned in the question this time, but the last one is the total number, so it's 40 this time. Now, how many staff members drank fewer than 6 glasses of water during a school day? So these are the number of classes. So this one says 4 less than or equal to x less than 6 is 13. So everything below that is less than 6. That means 5, 15 and 33 is below 6 classes. So the total number 5 plus 15 plus 13 is 33. So 33 teachers drank less than 6 classes. Now 2.4, the staff committee observed that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to fewer than 2. That means in this interval. Half of the K, that means half of the K means K over 2 or half K belong to this interval. That means 5, it's not 5 anymore. The number of staff members are not 5 anymore. It's going to be 5 plus K over 2. Now, while the remainder of them, half of them in this group, remainder of them drank from 4 to fewer than 6 in this interval. So the remaining half is in this interval. When these K teachers were included in the data, the estimated mean is 4 glasses of water per staff member per day. Okay, that also tells you how to find the mean here. So mean of a frequency table with a class interval is, this is the formula for mean when there is a frequency column. The formula becomes sigma fx over sigma f. That is a formula now when there is a frequency column. But here the x is the mid x. That means you need middle x, you need that to find the mean. So middle x is easy to find. 0 plus 2 divided by 1. So in this case it's 1. Here the middle value is 3. Here the middle value is 5. Then 7 and 9. So sigma fx. So the mean is already available. So the mean is 4 here. Let's find the fx. That means x times f. So it's f is 5 here. X is 1. Sorry, not 5 here, because now you added the teachers who were absent. So they are in the first interval. So now it's not 5 anymore. The frequency now becomes 5 plus. So x is 1 here, and the frequency is 5 plus k over 2. That is fx for the first row. Plus, then it's 3, no change in the frequency there. So it's simply 3 plus 15 plus. For the next one, it's going to be 5 times, now here also the frequency changed, it's going to be 13 plus k over 2 plus next one, it's 7 times 5 plus the last one 9 times 2 divided by that whole divided by sigma f, which is no longer 40 now, it's going to be 40 plus k. So we are finding the mean, which is already available. Let us cross multiply here. So it's going to be 4 times 40 plus k equal to, here it's just 1, so I'm leaving it as 5 plus k over 2 plus 3 times 15, 45 plus 5 times 13 plus k over 2 becomes 5 times 13, 65, opening the bracket there. Then this is now 5k over 2 plus 7 times 5, 35 plus 9 times 2, 18. Now it's an equation. The only unknown is k, so solve the equation to get the value of k. So the left hand side, now it's 4 times 40, 160 k, sorry, not k, 160 only there, 160 plus 4k, 160 plus 4k equal to, let's add everything on this side. Now when you add all the numbers, you get 5 plus 45 plus 65 plus 35 plus 18 will give you 168. So it's going to be 168 when you add all the constants together. Then you also add the coefficients of k. K over 2 plus 5 over 2 is 3. 5 plus 1, 6 over 2. It's going to be, so it's 3k. That means 4k minus 3k, it becomes k equal to 168 minus 160 is 8. So the value of k is 8 here. How many teachers were absent on the day of the interviews? That is k, which is 8. Okay, let's go to question number 3. Question number 3, we have in the figure L negative for 1 S and N are the vertices of a triangle having SLN equal to 90 degree. LN intersects the x-axis at K. Everything is marked in the diagram. That's what we need to check first. Then calculate the length of SL. Leave your answer in third form. So that's a direct question. So we can say 3.1. You are just finding using the distance formula to find the distance between S and L. So it's the formula, you use the formula from the formula sheet, x2 minus x1 square plus y2 minus y1 square, which will give you square root of, in this case it's S and L. Okay, so it's 4 minus 4 square plus 5 minus 1 square. And when you put this in the calculator, and also you only want the answer in third form, so the answer is 4 root 5, 2 marks. Now 3.2, calculate the gradient of Sn. Gradient of Sn, again we use the formula y2 minus y1 over x2 minus x1, which is equal to, so it's S and N now. So this is x1 y1 and x2 y2. So y2 negative 3 minus 5 divided by negative 2 minus 4. So the gradient you will get 4 over 3. Okay. Now the question is, calculate the size of theta, the angle of inclination of Sn. So already given that is the angle of inclination of Sn. So the only one formula about angle of inclination is m equal to tan theta. So 3.3, we are going to use the formula m of Sn in this case equal to tan theta. And you are finding theta, so it's theta equal to tan inverse the gradient. Gradient we already have, which is 4 over 3. Therefore, theta equal to 53,13. Okay, now you are asked to find the size of LNS. So let's go to the diagram to see where is LNS. LNS. So this is the angle that you are asked to find. So you're asked to find it. Let me call it, we can just call it N then. So when you are asked to find an angle here, look at the angles of inclination. Just now found that this is 53,13. That means this angle is also 53,13, vertically opposite angles. Now we can find another angle of inclination here, which is the angle of inclination of LN. Let me call it alpha. You can mark alpha in your answer sheet. Now again the same formula, m equal to tan alpha now, where m, the gradient, is the gradient of Ln. So in 3.4, okay, let me write 3.4 here. For 3.4, we are going to use the formula tan alpha equal to gradient of Ln. But we don't have the gradient of Ln here. So first we have to find the gradient of Ln, which will be y2 minus y1 divided by x2 minus x1. So which will give you 4 over negative 2. So it's negative 2. That is answer. So alpha equal to tan inverse negative 2, which will give you an answer that is negative in the calculator. The moment you see negative answer, you must know it's in the second quadrant. So it's 180 minus the answer, which is 63, comma 43. So alpha is 116, comma 57. That is angle alpha. So we go to this and angle also now, 116, comma 57, which is an exterior angle of this triangle. So this angle N plus 53, comma 13 must give you 116, comma 57, because that is now an exterior angle of a triangle. So therefore angle N is equal to 116, comma 57 minus 53, comma 13, which gives you 63, comma 44. That is angle N. Now determine the equation of the line which passes through L and is parallel to Sn. Okay, so the word parallel is given here for us to identify the gradient of the line. It's parallel to Sn means gradient of the line is equal to the gradient of Sn. That is the meaning of it. So Sn, we already have the gradient of Sn, which is 4 over 3. So the gradient of the line is also 4 over 3. So if the gradient is 4 over 3, we can write the equation as y equal to 4 over 3x plus c. Now one point on the line to substitute to get the value of c, that is only one point L, which is negative 4, 1. So let's substitute negative 4, 1. So y is 1 and x is negative 4 plus c. So when you simplify, you get c equal to 19 over 3. So the equation of the line parallel to Sn will be 4 over 3x plus 19 over 3. That is the equation of the line. Okay. Now 3.6, calculate the area of triangle LSN. This time LSN, it's already given that it's a right angular triangle. So the area, if you can use the formula half BH, where the two perpendicular sides are the base and the height. So here it's the base. You can, if you take this as the base, the height will be LS. So the area is going to be area of LS. So let's say 3.6 here now. 3.6. Area equal to half times, this was LS and LN. So it's LS times LN, which is equal to, so do we have LS? We found LS, we have it, but we don't have LN. So before we continue, let's find LN. LN using distance formula, square root of x2 minus x1. So L, we have a negative 4, 1. So Ln will be negative 4 minus minus 2 square plus y2 1 minus minus 3 square. So Ln is going to be 2 root 5. So Sn we already have, Ls we already have 4 root 5. So therefore the area now, area equal to, area is therefore half times 4 root 5 times 2 root 5, 2 and 2 cancels, 4 times 5, 20 square units. So that is the area of LSN. Now 3.7, calculate the coordinate of point P which is equidistant from L, S and N. Equidistant. So equidistant already tells you equal distance from, so it's a point P which is equidistant from L, S and N. So it can be equidistant from. Equidistance already means that all this L, P, Pn and Ps are radii of the circle. That is the meaning of it. Especially because this is 90 degree. So if this is 90 degree, LSN is the diameter then. So only diameter subtends 90 degree. So the point P is the midpoint of Sn. So it's because diameter subtends 90 degree. So here 3.7 you can write subtends 90 degree. Therefore P is the midpoint of the 2 points N and S. Did I write S anyway? No. Let me write 4, 5 and minus 2, 3. So we are going to substitute, we are going to find the midpoint of 4, 5 and N is minus 2, minus 3. Minus 2, minus 3. So P is the midpoint of that. So it's 4 plus minus 2 divided by 2 and 5 plus negative 3 divided by 2. So the point P is going to be 1 and 1. That is the coordinate of P. Calculate the size of angle LPS. So we must look at the LP. So LPS means you are asked to find this angle. It's an angle at the center of the circle passing through SLM. So these two are radii now. So these two angles are equal. So you can find this angle, third angle in the triangle. Now let's start by finding angle X. So we just now found N. It is 63,44. This angle was 63,44 here. So in this triangle you can find this angle. It's 90 minus 63,44 will be 26,56. So because these two are radii, this angle will also be 26,56. So we can start by saying PL equal to PS. That's what we first say. For 3.8, PL equal to PS radii. So angle S equal to angle SLP angles opposite equal sides. I already wrote equal there. Angles opposite equal sides, and we also found it, which is equal to 26,56. 26,56. Therefore angle LPS is equal to 180 minus those two angles, 26,56 plus 26,56, because sum of angles in triangle. That means the answer is 126,88. That is LPS. Okay, that was all in 3.8. Now we are going to question number 4. In the diagram, the circle with center O has the equation x square plus y square equal to 20, and GT0 is the center of the larger circle. A common tangent touches the circles at D and F respectively, such that D P negative 2 lies in the fourth quadrant. Okay, which is not marked here, so our first step is to mark the point D, which is P negative 2. It wasn't marked here. So this point is P negative 2. Make sure that all what is given in the question is marked in the diagram, and it lies in the fourth quadrant. Okay, let's go to the questions. 4.1. Given that DP negative 2 lies on the smaller circle, show that P equal to 4. So we already have the equation of the smaller circle, which is x square plus y square equal to 20. So 4.1. Given that the circle is x square plus y square equal to 20 and D is a point on the circle which is P negative 2, substitute for x and y. That means P square plus negative 2 square equal to 20. That is P square equal to 16. Therefore, P equal to plus or minus 4, but because it's in the fourth quadrant, you choose positive 4, because in the fourth quadrant x is positive. So P equal to 4. So that's what we have to show there. Now, so that also means D, the coordinate of D is 4, negative 2. Okay. Now E62. So this is a point 62. E62 is the midpoint of DF. Determine the coordinates of F. So if you already have the 2 point including the midpoint, and if you're asked to find the end point, you still use the midpoint formula 4.2. So let F be xy, which we don't know. So the midpoint we know it's 62. So x plus 4 divided by 2 is the x coordinate of the midpoint, and y plus negative 2 divided by 2 is the y coordinate, equal to y coordinate of the midpoint, that is 2. So here you get x plus 4 equal to, cross multiplying, 2 times 6, 12. Therefore, x equal to 12 minus 4, 8. Here y plus negative 2 equal to 2 times 2, 4. Therefore, y equal to 4 plus 2, 6. So the coordinate of F is 8, 6. So now we also have the coordinate of F, which is 8, 6. Writing all what we found in the diagram will help us finding more in the coming questions. So now 4.3, determine the equation of the common tangent DF in the form y equal to mx plus c. Common tangent DF. So we are supposed to find the equation of DF. We already have the 2 points on that, so gradient is not a problem. You can just find the gradient of the line and then use 1 point to get the value of c. So df 4.3. The equation is y equal to, so let's start by finding the gradient of df. We can use the any 2 points. Let us use the positive points 8d and f and e. So it will be y2 minus y1 divided by x2 minus x1. So it's 4 divided by 2, that is 2. So therefore the equation of df is 2x plus c. Let us substitute 1 point. Let's substitute 8 6. So 8, if you substitute the any point, you can substitute any point there. Let me substitute 8 6. So y is 6, x is 8 plus c. Therefore c equal to 6 minus 16, which is negative 10. So the equation of df is therefore 2x minus 10. That is the equation of df. Okay. Now calculate the value of t. Show all working. Okay. T is actually the center of the bigger circle. We just now found that the gradient of the tangent is 2. So we know tangent perpendicular to radius. So therefore the gradient of FG, which is the radius, is equal to negative 1 over 2, the reciprocal with opposite sign, because radius perpendicular to tangent. That means now what are we asked to find? We are asked to find the value of t. So we can use the same formula to find the t. So gradient formula, if you apply the formula here in this equation, it's y2 minus y1 over x2 minus x1 is equal to negative 1 over 2. Cross multiplying 6 times 2 is 12, equal to negative 1 times 8 minus t, that is 12, equal to negative 8 plus t. Therefore t equal to 12 plus 8, 20. That is t. So that also tells us that the center of the circle is 20, 0. That is the center of the circle. Okay. So we found t. Now 4.5, determine the equation of the largest circle in the form ax square plus by square plus cx plus dy plus e equal to 0. So we have the center now, which is 20, 0. So if you have the center, you can always write the equation of the circle like this. Okay, let's use this place. So for 4.5, the equation is x minus 20 square plus y minus 0 square equal to, that is the equation of the circle. Now we need to find the r square. That is obtained after substituting 1 point on the circle. The only 1 point that we know on the circle is 8 6. So let us substitute 8 6 to get the value of r. That means we are going to substitute 8 6 in this equation because it's on the circle. So it's 8 minus 20 square plus 6. 6 minus 0, you can just write 6 square equal to r square. That gives you the r square. So when you simplify this, you get r square equal to 180 when you put this in the calculator. Therefore, the equation of the circle is now x minus 20 square plus y square equal to 180. But this is not how we want the equation. We want it in this form. That means you expand, which will give you x square minus x minus 20 times x minus 20 gives you 40x plus 400 plus y square minus 180 equal to 0. Now when you're writing this form with x square first, then y square minus 40x, then 400 minus 180 is 220 plus 220 equal to 0. That's how the question is asking us to write. So that is the equation of the circle. Now 4.6, a smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. So in this case, you must also know that condition where a circle touches internally. A circle touches internally means there is a one circle like this, another circle touches internally, it's like this. In this case, if the distance between the centers will be a difference between the radii of the two circles. Radii of the bigger circle minus radii of the small circle is the distance between the centers. So if you know this idea, then you can do this problem very easily. Smaller circle must be translated by k. So in this situation, what happens here is the smaller circle must come actually only to the right, because if it goes translated to the left, it's never going to touch the circle. So it's supposed to be translating to the right, then it must translate so that it touches the bigger circle internally. So it should touch this many units, no, up to the center of the circle. This is the value of k from here until here. That is the value of k that you are going to find. That means you just need the center of this circle after translation. Okay, so we can use the same a result like this one. We know the distance between the center is going to be the difference between the two radii. Do we have the two radii? We have the radii of the bigger circle, which is square root of 180. So let's start with that. 4.6. Radius of the bigger circle is, let me call it, okay, it's square root of 180. Square root of 180 is 6 root 5. Now a radius of smaller circle is also, you already know, you already found it. Did we ever find? Yeah, it's square root of 20. Square root of 20, which is 2 root 5. Now we know that the distance between the center is equal to, if it touches internally, distance between centers is equal to the difference between the radius. So let's find the distance between the centers first, which is going to be square root of, we know the center of the two circles, it's 0, 0, the smaller one, no, sorry, not the 0, 0. Now the k units translated, so the new center of the circle, let me show it in the diagram. So the new center of the circle here is going to be k0. This is k0, k0. This is 20, 0. So the distance is this distance. This will be equal to the bigger radius minus smaller radius. So this is some smaller radius here, r, and here is the bigger radius, r. So r minus r is the distance between the centers. So here distance between the centers is now going to be x2 minus x1 square plus y2 minus y1. It's actually it's just 20 minus this is the distance. So now, so which is equal to, so we are going to substitute in this formula the distance between the centers, which is this one, that is square root of 20 minus k square is going to be equal to 6 root 5 minus 2 root 5. Now, which is actually 4 root 5. Now you're going to square on both sides. That will give you 20 minus k square is equal to, when you square 4 root 5, you get 80. 16 times 5, 80. Now we are going to simplify this further. Let us simplify, which will give you 400 minus 40k plus k square equal to 80. That means k square minus 40k minus 320 equal to 0. You can use a formula k equal to minus 40 plus or minus square root of b square minus 4ac, the whole divided by 2a. We are going to get r k equal to 20 minus 4 root 5 or k equal to 20 plus 4 root 5. It's 20 minus, the answer is 11,06 or k equal to 20 plus is 28,94. 28,94. These are the two values, possible values of k if the circle touches internally. Okay, let's go to the next question. Let's go to question number 5. Given sin beta equal to 1 over 3 where beta element of 90 to 270 degrees, then calculate the following. Okay, beta is between 90 to 270 means not in the first quadrant, but sin beta the value is positive. So we can draw the diagram to make it easier. The diagram comes in the second quadrant because sin beta is positive. So this is angle beta. Now this is a right angle triangle. Sin beta opposite over hypotenuse, so it's 1 over 3. We can find the x now using the theorem of Pythagoras. X square plus y square equal to r square. That is x square plus 1 square equal to 3 square. Therefore x equal to square root of 9 minus 1, which is 2 root 2. But it's plus or minus 2 root 2. You choose negative 2 root 2 because we are in the second quadrant. So here x is equal to negative 2 root 2. Therefore cos beta is adjacent over hypotenuse. So it's negative 2 root 2 over 3. Now 5.1.2 sin 2 beta. Sin 2 beta, use the double angle formula. which is 2 sine beta cos beta. Give the values of sine beta and cos beta. Sine beta is 1 over 3, already given. Cos beta is just now found, it's 2 root 2 over 3. If you simplify further, it's not a lot of simplification, it's negative 4 root 2, just multiplying the top and the bottom, that's negative 4 root 2 over 9. 5.1.3 cos 450 minus beta is equal to, so an angle more than 360, you simply subtract 360. 450 minus 360 is 90, so this becomes 90 minus beta, which is sine beta, which is 1 over 3. Now 5.2, given this identity, prove that this equal to 1 minus sine x. So let's start for 5.2.1. Let's start with the left hand side. Left hand side equal to, okay, when you look at the left hand side, there is something common, a common factor on top, which is cos square x. So let's take the common factor out. Common factor is cos square x times another cos square x still remaining, out of the cos to the power 4x plus sine square x, the whole divided by 1 plus sine x, which is equal to cos square x times 1 divided by 1 plus sine x. But looking at the right hand side, we don't want cos square x in the left hand side. Let us change the cos square x to 1 minus sine square x divided by 1 plus sine x. So looking at the denominator and the right hand side, you still have to factorize the numerator to 1 minus sine x times 1 plus sine x. Now the numerator 1 plus sine x and the 1 plus sine x in the denominator cancel each other. You are left with 1 minus sine x, which is the right hand side. So you proved. Now 5.2.2, for what values of x in the interval x from 0 to 360 is this undefined? Undefined when the denominator equal to 0, that means 1 plus sine x equal to 0, that means sine x equal to negative 1. We are solving the equation now. Reference angle is sine inverse 1, which is 90 degree. So the two, because it's from 0 to 360, we are going to consider the two quadrants where sine is negative. Third quadrant and fourth quadrant. So the answers are x equal to third quadrant will be 180 plus 90. You don't have to find other k360 because the answer is only from 0 to 360, only considering the two quadrants here. So x equal to fourth quadrant answer is 360 minus 90, which is also 270. So only one answer. This also gives you 270. So only one answer, x equal to 270. Okay. Write down the minimum value of the function defined by y equal to. So this one we already simplified. That function is equal to 1 minus sine x. So to find the minimum value, we must simplify this to a single trigonometric ratio, an expression including single trigonometric ratio, so that we know the minimum. Let us find the minimum of, it's actually minimum of negative sine x, that is a trigonometric ratio here, plus 1. We already know that minimum of the sine function is 1 or negative 1. Here it's not the sine function, it's the negative sine x, so it's this one. But still the minimum is negative 1, the maximum is 1. So minimum is negative 1 plus 1. So it's equal to minimum of negative sine x is negative 1 plus 1. So the minimum is 0. Now 5.3, cos a minus b equal to cos a cos b plus sin s, it's given. Use the above identity to deduce that sin a minus b equal to sin a cos b. Stop. Use the above identity to deduce that sin a minus b equal to sin a cos b minus cos a sin b. Only 3 marks. So we already have this one. This is what we have. We must use this identity to solve this. So we are going to solve for sin a minus b. So to find, we can only use this formula, that means the cos a minus b formula. So first step is to change the sign to cos. So sin a minus b is actually cos 90 minus a minus b. That's how we can change the sign to cos. But still, it must be changed to this one. So let us expand first. Cos 90 minus a, it should be a minus b, so I'm going to write it minus minus b. So 90 minus a is going to be together as a here as the first angle, then as b we have a minus b. Now, so this is the a part. This whole thing stands for a in the formula, and this stands for b in the formula. Let us apply the formula as given. Cos a minus b is cos a cos b plus. So we are going to say cos, our a is 90 minus a, cos b, b is negative b, plus sin a, sin a is 90 minus a, and sin b, b is negative b, which is equal to cos 90 minus a is sin a, cos negative b is positive cos b, plus sin 90 minus a is cos a, and sin negative b is negative sin b. That negative will come here now. So final step, sin a cos b minus cos a sin b, we proved. So what we proved is sin A minus B equal to sin A cos B minus cos A sin. Okay, let's go to 5.3.2. Hence or otherwise determine the general solution of the equation sin 48 cos x minus cos 48 sin x equal to cos 2x. So this is the compound angle formula for sin A minus B. So it's 48 minus x equal to cos 2x. So you have to change one of them to sine. So let's change this part. So it's sine 48 degree minus x equal to, let me say it's sine 90 minus 2x. Take the one on the right as the reference angle, 90 minus 2x. So the two quadrants where sine is positive are first and second quadrant. So the answers are 48 minus x, which is the angle on the left, is equal to 90 minus 2x, reference angle, plus k 360. Here 48 minus x is equal to, second quadrant means 180 minus reference angle 90 minus 2x plus k 360, k element of z. Here while we simplifying, the minus x plus 2x makes it x. Then bring the 48 to this side, 90 minus 48 will give you 42 degree plus k 360. That is one answer. K element of z. There is no more simplifications. Then the other answer will be, this side we need some simplifications, negative x, and here when you open the bracket it's plus 2x. When this comes to this side, minus 2x equal to 180 minus 90 minus 48 gives you 42 plus k 360, which is minus 3x, which is minus 3x equal to 42 degree plus k 360 dividing by negative 3 throughout. The final answer is x equal to negative 14 degree minus k 120, k element of z. So another answer. So these are the two general solutions. Okay, let's go to 5.4. Simplify this to a single trigonometric ratio. Okay, so we take the expression sine 3x plus sine x divided by cos 2x plus 1, which can be written as, looking at the 3x and x, you can change the numerator to sine 2x plus x plus sine 3x minus x. the whole divided by cos 2x plus 1, which is equal to, now we are going to expand this using the compound angle formula. This will give you sine 2x cos x plus cos 2x sine x plus, sorry, I made a mistake by putting 3 here, it's 2x sine 2x minus x will only give you x. Okay, so this is sine 2x cos x minus cos 2x sine x. So we can already see these two are can cancel. There is still a denominator, cos 2x plus 1, which is equal to, so this is now 2 times, because they are like terms, so 2 times sine 2x cos x divided by cos 2x plus 1, which we can simplify further. We can apply the formula now. That will give you 2 times sine 2x alone is 2 sine x cos x times another cos x is still there divided by, also let us simplify, because now there is no 2x on top, so let us change this, use the formula that will cancel the plus 1, which can be 2 cos square x minus 1 plus 1, which gives you 4 sin x cos square x on top, and in the denominator 2 cos square x. Cos square x cancels, 4 and 2 cancels, on what is remaining is 2 sin x, that is single trigonometric ratio. Okay, let's go to question 6. Question 6. In the diagram, the graph of f of x equal to 2 sine 2x and g of x equal to negative cos x plus 45 were drawn for the interval x element of 0 degree to 180 degree, and a lies on f. Everything is marked there. 6.1. Write down the period of f. Period of f is 2 sine 2x, so there is a coefficient of x, so the period is 360 divided by the k value there, which is 2. So the answer is 180 degrees. 6.2. The question is, determine the range of g in the interval x from 0 to 180. G is the cos function. G was negative cos x plus 45 degree. Okay. The amplitude is still 1 because it's negative 1 here. So amplitude is, so it's from the mother graph, it hasn't gone up or down. So the amplitude is, so the minimum is still negative 1 and maximum is 1. So the range here in this interval, it's from here until the maximum point. Maximum point we know it's 1, but the minimum point we are not very sure. So you put x equal to 0 in the function to get what is the y value. So the function is f of x equal to, sorry, not g of x. So here 6.2, the function is g of x equal to negative cos x plus 45 degree. When x equal to 0, what is a y? y will be negative cos 0 plus 45 degree, that is negative cos 45, which is negative root 2 over 2. So therefore the range of gx in this interval is starting from here. When x equal to 0, the y is negative root 2 over 2 until 1. That is a range. Now determine the values of x in the interval x from 0 degree to 180 degree for which fx times g of x greater than 0. So you check where is it negative and positive. This is where g is negative, and after the 45 degree g becomes positive. Here f is already positive. All these places it's positive, 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 and here it's negative. So the product greater than subproduct must be positive. So negative times positive, here it's negative. Then after 45 degree, both are positive, so the product will also be positive until 90. After 90, one is negative, the other one is positive. So both positive only from 45 degree to 90 degree. So the answer for this one, you can say x between 45 degree until 90 degrees. 6.3.1. Now 6.3.2, f of x plus 1 less than or equal to 0. 6.3.2, f of x plus 1 means f of x less than or equal to negative 1. Where is f less than negative 1? It's here. This is negative 1. Less than negative 1 is this point from here to here. Corresponding x value is from here. The a here it's 105. You must also find this value. You can use a symmetry to find that value. 105 is 15 degree more than 90. So this point will be 15 degree less than 180, which will be 165. So it's less than 1 for x between 105 degree until 165 degree. That is where fx is less than 81. Now in 6.4, another graph P is defined as fx equal px equal to negative f of x, dk negative 1 lies on P. Determine the values of k in the interval 0 to 180. Okay, so we can write 6.4. We can write the equation of p of x. P of x is negative fx. That means negative f of x is 2 sine 2x. This is p of x. Let us substitute the point dk negative 1 on p of x. So y is negative 1, x is sine 2k, negative 2 sine 2k. Now therefore sine 2k, one over 2, reference angle is sine inverse half, that is 30 degree. So where sine is positive, 1 and second quadrant, only 1 and 2 because it's only from 0 to 180. Now that means 2k equal to, you don't have to use the k 360 this time, only from 0 to 180. So in the first quadrant, reference angle itself 2k equal to 30 degree, and here 2k equal to 180 minus 30 degree. That means k equal to 15 degrees, or 2k equal to 150 degree. That means k equal to 75 degree. So the two values of k in the interval 0 to 180 is k equal to 15 and k equal to 75. Now 6.5, graph H is obtained when G is translated 45 degree to the left. So Hx is equal to 45 degree to the left. G is so G is already negative cos. So G is negative cos x plus 45. But now 45 degree to the left means x becomes x minus plus 45. Already there is a 45 degree. So which is negative cos 45 plus 45 makes it 90 plus x. But 90 cos 90 plus x is negative sin x. So it becomes positive sin x. Determine the equation of hx. So hx is positive sin x. That is question number 6. Okay, let's go to question number 7. In the diagram, S, T and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. TSK equal to alpha. T is equal to P meters, and the area of triangle STK is Q meters square. Determine the length of SK in terms of P, Q and alpha. SK is here. Okay, because Q is also must be needed in the answer, we need to use the area also. So let's start by writing the area of triangle STK. So here, because triangle STK is not a right angular triangle and we don't have any height, so area is the area rule here, half times the angle given in the triangle is alpha. So we can use the two sides between angle alpha, which is ST times SK times sine of angle alpha. That's what we are going to use for 7.1. Area is already available, which is Q, equal to half times ST is P, SK we don't know, we are going to find SK, sine alpha. We know everything except SK, so cross multiplying 2Q equal to P sine alpha times SK. Multiplying both sides by P sine alpha to have SK alone in one side. P sine alpha, you get SK equal to 2Q divided by P sine alpha. That is SK. We were asked to find SK in terms of P, Q and 7.2. Show that R is equal to 2Q tan alpha divided by P sine alpha. Sorry, tan beta. So because the angle beta is coming in the answer, you must go to a triangle RSK. This was angle of depression. That means angle of elevation is also beta. These two angles are equal. So tan of angle beta, the answer already gives you an idea that in this triangle we are going to apply the trigger ratio tan. So tan beta is opposite over adjacent. So that's why where we are going to start in 7.2, tan beta. Tan beta equal to S over SK. Therefore, what is SR, which is RS, is SK times tan beta. But SK we already know it's this one. So which is equal to 2Q tan beta over P sine alpha. We just substituted for SK, which is 2Q over P sine alpha. So we showed that RS equal to, which is SR, that is RS. Now 7.3, calculate the size of alpha if A is less than 90. Sorry, alpha is less than 90 and R is equal to 70. But all the values are given, everything given. Calculate the size of alpha. Okay, so we just have to substitute all these values in this equation here. So let me write it here. 7.3. So the equation is RS equal to 2Q tan beta over P sine alpha. We are going to substitute everything. RS is 70 equal to 2Q. Q is 2500 times tan beta is 42 degree, the whole divided by P. P is 80 times sine alpha. Now we have to make sine alpha the subject of the formula. So bring the sine alpha here and 70 this side. So sine alpha equal to 2 times 2500 times tan 42 divided by 80 times 70. We brought the sine alpha here and 70 here. Now put this in the calculator, which will give you which will give you 53, that is. So you were asked to find it. That is question number 7. Let's go to question number 8, Euclidean geometry. In the diagram, O is the center of the circle. Use the diagram above to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. Okay, so first part is the construction of the diameter here. You construct the diameter. Then that is also dividing the angle into K1, K2, O1, O2. So we start by saying OK. OK equal to OT, because now they are radii of the same circle. That means K1 is equal to T, because they are now angles opposite equal sides. Now angle O1 equal to K1 plus T, because they are exterior angle of a triangle. But K1 equal to T1. So this is K1 plus K1, which is 2K1. So what we found is O1 equal to 2K1. So now you can say similarly O2 is also equal to 2K2. Now O1 plus O2, which is asked TOP, is therefore equal to 2K1 plus 2K2. That is TOP is equal to 2 times K1 plus K2, which is called TKP. You proved. Or maybe you can also write one more step, which is 2 times K1 plus K2. Which is TKP. You proved. That is 8 point. Okay, let's go to 8.2. In the diagram, O is the center of the circle and ABCD is a cyclic quadrilateral. OB and OD are drawn. If O1 is given as 4x plus 100 and C is x plus 34, calculate giving reasons the size of x. Okay, what is given is this angle and angle C. Okay, so if you know this angle, you can always find angle A, because we know O1 equal to 2 times A, because of the theorem, angle at the center equal to 2 times angle at the circumference. That means O1 is 4x plus 100 equal to 2A. Therefore, A is you divide by 2 on both sides. Therefore, angle A equal to 2x plus 50. Now that means now you go to this angle A. Now look at the cyclic quadrilateral ADCB or ABCD. Then these two are opposite angles of the cyclic quadrilateral. So you can say angle A plus angle C equal to 180, because opposite angles of a cyclic quad. That means 2x plus 50 plus x plus 34 is equal to 108. That is 3x equal to, you subtract 180 minus 50 minus 34, that will give you 96, dividing by 3, x equal to 32 degrees. That is x, 5 marks. Now let's go to question number 9 now. Question number 9. No, it's not 9. 8.3. 8.3 says, in the diagram, O is the center of the large circle, OB is a diameter of the smaller circle, chord AB of largest circle intersects with the smaller circle at M and B. Write down the size of OMB, provide a reason. So you can see OB is the diameter here. So M is angle subtended by the diameter. So angle OMB is equal to 90 degree. Reason is angle in a semicircle. Now 8.3.2, if AB equal to square root of 300 units and OM equal to 5. So this is 5 units and AB is square root of 300. Giving reasons the length of OB. So we just now found that this is 90 degree. So if the line from the center to the chord is 90 degree, then it bisects the chord. So that's what we are going to write first. We can say AM equal to MB because perpendicular from center to chord. Perpendicular line from center to chord bisects the chord. So that is the reason why AM equal to MB. That means MB is equal to half of square root of 300. Now we can use the theorem of Pythagoras. OB square is equal to OM square plus MB square. OM is 5 square plus square root of 300 over 2 square. Now you take the square root of, so OB is actually the square root of this. You can put this once in the calculator. You get OB equal to 10 units. Another 4 marks. Now we are going to question number 9. In the diagram, ABCD is a parallelogram with AB equal to 14 units. AD is produced to E such that AD is to DE equal to 4 is to 3. So you can mark it in the diagram. AD is to DE is 4 is to 3 means 4K is to 3K because these are 4 and 3 are not the original length. Now EB intersects DC in F. EB intersects, okay, F. EB is 21. So the total length of EB is also available, which is 21. So that's the original length, 21. Now first step is calculate with reasons the length of FB. Okay, FB. So this is a parallelogram. So these are parallel lines in a triangle. If there is a line parallel to one side, then you can apply the prop theorem. So you are finding FB. So let me start by writing FB over BE because that is available is equal to, we are finding FB and B is available. So because of the parallel lines, FB corresponds to AD divided by BE corresponds to AE. We can write it only because of the parallel lines. So we are applying prop theorem. So it's prop theorem, and because DC parallel to AB. Now let us keyboard what we know here. FB over 21 equal to AD is 4K over AE is 7K. It's the total length on this side. 3K plus 4K, 7K. So therefore FB is equal to, K and K cancels, 4 over 7 times 21, which will give you 12 units. Now prove with reasons that a triangle EDF similar to triangle EAB. So for 9.2, you can take in triangle EDF and triangle EAB. You can say, now we have to prove that. So it's EDF and EAB. Angle E is common angle. It's common. Then angle D is equal to angle A because they are corresponding angles, because DC parallel to AB. So F is also equal to B. Sum of angles in triangle. Therefore, triangle EDF is now similar to triangle EAB because all three angles are equal. Now 9.3, calculate with reasons length of FC. So we the other information in the question was, there was one more information about the length of AB. We were supposed to mark it here. So length of AB was given here. It was 14 units. So because it's a parallelogram, that means DC is also 14 units. So we are going to make use of that information to get the length of FC. So if you find the length of DF here, that will help us to find the length of FC, because we know the total length is 14 units. DC is 14 units. So our aim is to find the length of DF. So we can make use of the similar triangles that we found just now. So because these two triangles are similar, we can write the ratio. Let us take the ratio that has DF. So let me write DF over AB. DF corresponds to AB equal to EF or ED. I think we have ED, so let me use ED over EA because similar triangles. ED over EA equal to DF over AB. That's what we wrote. So the only unknown is DF now. DF over AB, we know it's 14 units, equal to ED. ED is 3K over EA is 7K. So therefore DF equal to K and K cancels, 3 times 14 divided by 7, which is 6 units. So we found DF. Therefore FC equal to DC minus DF, which is 14 minus 6, 8 units. That is the length of FC. That is question number 9. Let's go to question number 10 now. In the diagram, PQRS is a cyclic quadrilateral such that PQ equal to PR. So it's not marked here. So let's mark PQ equal to PR. The tangent to the circle through P and R meet QS produced at A, RS is produced to meet tangent AP at B, PS is produced to meet tangent AR at C, AR, PR and QS intersect at M. First question, prove giving reasons that angle S3 equal to S4. It's a 5-mark question. Okay, when we are supposed to prove that two angles are equal, you write the two angles one after the other, S3 and S4. Let us find an angle equal to S3. S3 is equal to this angle is the exterior angle of this cyclic quadrilateral. So this will be equal to the interior opposite angle. So we can write S3 equal to Q1 plus Q2. The reason is exterior angle of a cyclic quad. Now check whether S4 is also equal to Q1 plus Q2. Is S4 equal to this one? We don't know. We have no idea about that one. So find another angle equal to S4. S4 is equal to R3 because they are angles in the same segment, PQ. PQ subtends S4 and also R3. So S4 equal to R3 because angles in the same segment. Okay, now check whether these two are equal. Is R3 equal to Q1 plus Q2? Yes, because it was given that PR equal to PQ. So R3 is equal to Q1 plus Q2. Angles opposite equal sides. So these two are equal, therefore S3 equal to S4. Okay, let's go to 10.2. Prove that SMRC is a cyclic quadrilateral. SMRC is a cyclic quadrilateral, so it's SMRC is a cyclic quadrilateral. So if you can prove that any exterior angle is equal to the interior opposite angle, because the diagonals are not drawn, we are not going to use angles in the same segment here, and we don't know if you can prove that the opposite angles are supplementary, then also it will become a cyclic quadrilateral. Okay, let's start with what we already found here is 3S4 such angles. So this is an exterior angle of this quadrilateral that we are going to find. S1 is equal to S4. Let's start there. Angle S1 is equal to S4 because they are vertically opposite angles. Now the S4 that we found is equal to Q1 plus Q2. We proved here S4 equal to R3 equal to Q1 plus Q2. So S4 equal to Q1 plus Q2 proven. Proven in 10.1. Now that Q1 plus Q2 is equal to R1 plus R2 because tan code there. So ultimately what we are trying to prove is S1 equal to R1 plus R2. Therefore, S1 equal to R1 plus R2. Therefore, SMRC is a cyclic quadrilateral. The reason is exterior angle equal to the interior opposite angle. That is why. So this is the exterior angle, it's equal to the interior opposite angle. Therefore, it's a cyclic quadrilateral. Okay, let's go to 10.3. Prove that RP is the tangent to the circle passing through PS and A at P. PS and A means there is a circle passing through P, S and A, and you have to prove that RP means this line. This line is a tangent to the circle here. So what you are ultimately going to prove is you have to prove that P2 equal to A2. This will be the tangent, and the chord, you are proving that angle between the tangent and chord is equal to the angle subtended by the chord. So you are required to prove that P2 equal to A2 here. Okay, so how can we prove that? to prove these two angles to be equal, so that is the first thing we are going to write. 10.3. You are required to prove that P2 equal to A2. So to prove those two angles to be equal, let us take the triangle MPA, MPA in triangle MPA and triangle PRC. PRC. Okay, before you write the name, you have to locate the triangles. So we are going to use MPA and we are going to use a triangle PRC. PRC. Let's see which are the angles used for MPA. MPA is by M2, P1 and 2, 1 and 2 together, and A2. That is a triangle MPA. Now PRC is P2, R1 plus 2, and C2. So here you have A2 and P2. Okay. Okay. We already know here. We already know that P1 plus P2 and R1 plus R2 are equal, because these are tans from the same point AR and AP. So this angle is equal to this one. Angles opposite equal sides. Now M2 and P2 are also equal. No, M2 and C2, M2 and C2 are equal because they are exterior angle of this cyclic chord that we just now found. So this is how they are related. So when we write the name of the triangle, it must be in order. So it's MPA, triangle MPA. M corresponds to C, so I start with the C. When I name the triangle, the second triangle, the angles must correspond, so it must be C, then P corresponds to R, then A corresponds to P. Automatically the P comes, so CRP. Now in these two triangles, let's start by saying M2 equal, we can start by saying M2 equal to C2, because exterior angle of a cyclic chord. Now P1 plus P2, P1 plus P2 is equal to R1 plus R2. It's because the reason is sides, angles opposite equal sides. Angles opposite equal sides. But then mention why the sides are equal. So you have to mention that AR equal to AP because tans from the same point. So now in these two triangles, already we proved that two angles are equal. So automatically, therefore, A2 equal to B2. The reason is sum of angles in triangle. In a triangle, if you prove that two angles are already equal, third angle automatically becomes equal. So we are proving if A2 and P2 are equal, RP is a tangent. The reason is converse tan chord theorem. So that is last question in this question paper. This was only suggested answers for this question paper. If you have other suggestions, please comment below. Thank you very much.